Welcome to the Maintainable Software Podcast, where we speak with seasoned practitioners who have helped organizations work past the problems often associated with technical debt and legacy code. I'm your host, Robby Russell. On this episode, we're joined by Liran Haimovitch, who is a co-founder at Rookout. Liran Haimovitch, welcome to Maintainable.
Great to meet you, Robby.
So in your opinion, what are some common traits of a maintainable software code base?
So I would say the two most important traits of a maintainable software code base is readability and testability. And even better if you already have tests in place.
When you say readability, is that from like a documentation perspective, or is that just how expressive the code itself is, or a bit of both?
It's a bit of both. I mean, people keep repeating it, and no matter how many people repeat it, it's still so important. You write a code once, you read it dozens, maybe sometimes thousands of times. That's what you have to keep in mind. It doesn't matter. It's about keeping the code clean and readable. It's about having comments. It's about having documentation, diagrams, whatever it takes. The easier it is for somebody who doesn't know the code to step right into it and grasp it, the easier it's going to be to maintain.
We want to dive a little bit into this, kind of readability. What do you think is important for a developer when they're leaving some comments or writing their code in terms of, is it to understand what is happening, or do you feel like there's something more to it than just being descriptive about what they're reading?
So it's a lot about keeping the abstraction layers. It's about writing your code in the right abstraction layer, using the correct variable names and function names for the abstraction layer you're working at, as well as making sure each abstraction layer is only doing one thing and that everything around it is based on it. The easier it is and the more consistent your abstractions are, the easier it's going to be for someone new to grasp it.
Do you find that sometimes developers are not necessarily good at, like they might describe what's happening or why it's happening? One thing I've heard a lot in some recent conversations is about understanding what like the original developer's intent was. And sometimes that gets lost in the process because there's a lot of what is going on, but not necessarily the why or how that even decided to be a need in the first place.
The why is probably the hardest thing for developers to document and leave for the next generations, in a manner of speaking. Often it's hard for us to even clarify for ourselves why are we doing things. It can be experience, it can be some malfunction, it can be just a hunch, but that's very important, the why. And it's kind of the reason why losing people and having developers move on is such a big loss, because the why is a lot of what's being left behind.
And you also touched on testability. Are there some common characteristics of what makes some software more testable than others?
A lot has to do with how do you isolate different pieces of the code? How can you run each of them by itself? How can you test a certain component with the various inputs and states it might have without being overly concerned about isolating it from the environment? And the thing is, it's very hard to predict how code will behave. And the most important thing when maintaining software is not to have any regression, to make sure everything you have keeps behaving the way it did before you made a change, except for the one thing you wanted to change. And tests are the best thing for that.
What are some things that you believe people get wrong about technical debt as a metaphor?
So what I feel people get wrong most about technical debt is what I like to call fake technical debt. It's actually knowledge gaps. It's when something works great, but nobody knows why it works, how it works. And so they figure out there's something wrong with the code rather than something wrong with the team. And so you take this piece of code that's been laying around for a dozen years and nobody touched on, and all of a sudden this piece of code is to blame.
When you think about technical debt, are there any specific projects that you might have been part of, like on the code level, that you remember that were quite difficult to work on due to the state of the code base?
So one of our customers had a small Python script that was in charge of taking all the usage patterns, usage sheets from their customers and totaling all of it, and then sending out the invoices for the various customers of the company. And that script was very, very old. Nobody knows who even wrote it. It was barely source controlled. There wasn't any CI/CD testing around it. they did most of the work by SSHing into machine and editing it manually. But about half the company's revenues depended on that script.
Wow. And so with that project that your clients were dealing with that scenario, what were some ways that they were able to start? Was a rewrite necessary, or were you able to, with their client, able to rectify that situation somehow?
They couldn't rewrite the code because they didn't have any tests. And the code itself was so based on inputs coming in from customers that were very hard to predict. And so it was very difficult to properly regression test any changes. There wasn't a clear spec of what's the expected behavior. They have mostly been living with it. They did use Rookout so that they could more easily debug it and understand what's going on. But due to the huge risks they saw from it, they decided to keep it as is with the aid of Rookout debugging.
Let's take a quick step back to learn a little bit more about you and Rookout. So what is Rookout and what inspired you to begin building it?
Rookout is a data collection and debugging platform which allows engineers to instantly inspect their code and collect any piece of data they want while the code is running on a remote machine. It can be servers, Kubernetes, or even serverless, and they can use Rookout to collect data and debug across the software lifecycle, be it development environments, QA, and even pre-production and production.
What technology or programming languages do you currently support?
Rookout currently supports anything running on JVM, including Scala, Kotlin, Clojure, Groovy, obviously Java, as well as Python and Node.js, including TypeScript and CoffeeScript.
You know, from my own ignorance about how the inners of your tool works so far, I watched a little video and kind of got like a little high-level overview of it. So is my understanding that you're able to, as a developer, is this something you run in a production environment or do you run it locally? You include some library or something, and then it gives you the ability to kind of inject some stuff into the code so you can extract?
You can run Rookout wherever you want, wherever you need to debug, wherever you need to collect data. All you have to do is install our SDK and set it up. Once you do that, it's going to connect to our service and allow you to instantly add non-breaking breakpoints to your code.
So are you able to then create like a little bit of a paper trail of everything that's happening kind of in real time, like as functioning your code base is getting run, and you can get a sense of what's going on at that point in time?
Yeah, you can select any function in your code, any line in your code essentially, and set the breakpoint there, and you're going to see variable values, stack traces, global state, anything you want. And it takes under a second to add and remove breakpoints. You can add as many as you want. And just get a very similar experience to what you're used to with a local debugger, except it's anywhere your code is running in the world.
Yeah, and how did you come about co-founding that? Was there a backstory, a reason why this was an area you were interested in kind of focusing on?
It's always been a pain for us. For my co-founder and me, we've been software developers for about 15 years or so. And it's always bothered us that once the code leaves our laptop, it becomes so hard to understand what's going on. And for crying out loud, it's our code running on our servers. Why do we have to work so hard to just get a piece of data from it?
And how long has Rookout been around now since you released it?
Rookout has been around for 2 years now.
And how does it differ from, say, other platforms or things like Datadog or New Relic? And, the way I always see like New Relic has been more of a way to kind of monitor how things are happening after they've had to look at performance things and see how long areas of the code base might take to contribute to performance issues. And I know they have a suite of products now. I think this ties a little bit more on the observability side of things, correct?
Most observability offerings in the market right now are focusing first and foremost on analyzing data, visualizing it, providing you with bottom lines and so on. But they can only provide you with a very strictly limited piece of data. You have to do all the hard work of going through the code, instrumenting it, and adding those data collection points as you develop. And once the code is in production or even in staging, that's it. It's frozen. In order to get a new piece of data, you have to add instrumentation and redeploy. Rookout allows you to instrument in real time, and you can even send the data to New Relic, Datadog, or any of the other players you mentioned.
That's great. Then as a target customer for Rookout, do you find that I'm sure it can work across the spectrum of startups to companies that have products that have been in production for a while? How early in the process of building a new web application or something, and you're going to be launching that, how early should you be thinking about this in your process? Or is this more geared towards a certain period of time when your product's been out in production for a while?
We're seeing it across the spectrum. We're seeing some companies use this as early as they start developing, especially for cloud native technologies such as serverless and Kubernetes, where development might be a bit hard. We are seeing companies prepare Rookout for the launch. So if they expect a plethora of new bugs opening, they want some new tool to allow them to work in the new and more secure and compliant version of production. And we're also seeing legacy software. We have a customer that has a WebLogic server that takes about 40 minutes to restart. And Rookout is the only tool they can use to debug it.
In a recent article on Jack Center, you conveyed that you felt that software developers might overuse, I'm air quoting, technical debt as an excuse a little too often. What do you mean by that?
So whenever somebody asks you for something you don't want to do, tech debt is kind of a catch-all excuse. Because it's hip lately. People have been talking about it a lot. There's obviously a great new podcast on it these days. And whenever somebody tells you, let's try and make the system do something different, let's make the software do this instead of that, the easiest thing in the world is to claim, I can't do it. Whoever originally designed it didn't plan for it. Now it's out of spec and it can't be done. And quite often it's not true. Sometimes the system was originally planned to do it. Sometimes you can easily adapt it to do it. But just throwing around tech debt is a magic excuse because managers find it hard to resist.
Is it safe to assume that even Rookout, you've accumulated some of your own technical debt, like real technical debt?
Yeah, we have acquired, I would say, surprisingly a lot of technical debt for such a young company. As an acting VP of R&D, I'm constantly surprised by the choices my co-founder and I made in his garage 2 years ago that keep biting us as we are scaling up to a bigger team, debugging tens of thousands of instances of servers.
What types of processes has your team put in place to help you manage that technical debt?
That's an interesting question. I would say two most important processes. The first is iterative change. Don't try to change everything at once. Take small steps. Be ready to roll back or revert if needed. Just take small steps in the direction you're heading and reduce the risk and build confidence. With every small step you make, you learn, you build confidence in the team, you add support, tools, tests, and so on. And you slowly move in the right direction and you gain more speed doing it. The second tool is, especially for backend and cloud systems, is running side by side. More often than not, you can create a new piece of code, a new microservice or a new ingestion flow or a new API, and just have it mimic the old API. And what we're often doing is use the facade to call both APIs, compare the results, and we only move to the new API after we've been convinced that they behave in the same manner.
I'll be back with my interview with Liran in just a moment. Hi, it's me, Robby. I wanted to thank you for listening to the Maintainable Software Podcast. If you're finding these conversations valuable, please consider sharing it amongst your peers and writing a review on Apple Podcasts to help spread the word. Go on, I'll wait. Also, should you be the type of person who has a plethora of great stories about improving the long-term maintainability of software and might like to share that with our audience? Please get in touch with me at Robby with a Y at maintainable.fm. And now, back to our interview with Liran. Out of curiosity, how large is your development or engineering team right now?
Our engineering team is about 12 developers right now.
I think you make a really good point with, slowly building more confidence within your team, because that's a kind of a subjective thing. What are some ways that you've seen your team do that? You mentioned testing. Is there other ways? And has there been any sort of other things that might not necessarily be technical in nature, but more on within your team on an education perspective?
It's important to understand that developers not only have to know their code, but they have to build a degree of confidence in it, and they have to be emotionally attached to it to a certain degree. I'm not saying they should be in love with their code, but they shouldn't dislike it either. I've seen developers being onboarded poorly, ending up disliking the code they're in charge of and just searching for any excuse to rewrite it. It's very important when you bring on a new developer, you have to teach him about the code. You have to start him out with simple tasks as small as possible, sometimes even one-line bug fixes or one-line feature changes, so that they can get a grasp of how the system is working, see how to build it, learn how to test it, roll out a new feature with it, and gradually become a part of it.
It's a really important point there. Developers are being onboarded to a project, and it's interesting because in my profession, what we focus on, we're a software consultancy, so we're working on other people's code bases most of the time. We're onboarded to lots of different software projects every year, and we've learned that even our most experienced developers, we never commit to doing any really large projects or feature additions initially. It's always going to be, all right, we know that like a client will come to us like, hey, we need help with this big product backlog and there's a bunch of features we want to add or some pretty big nasty bugs that keep reappearing. We want you to look at that. And we'll be like, that's great. First of all, we're going to go, after we get someone acclimated with your code base, do like a code review, let's start looking for some small bug fixes that we can probably take care of in a very relatively short period of time. So not only can we make changes to the code base, fix a bug, be able to push it out to your staging environment, see you get it tested, push it to deploy it to production, and see it get fixed out there, and then close a ticket together, maybe in a half a day together with our client. We now not only have learned a little bit about their code base, and we can make some changes to it in case something goes down, because there's a lot of other things that come into that process, but we're also establishing some confidence in ourselves that we can work on the application. We're establishing confidence in our clients that we can go through the process. And if that process is really convoluted and problematic, usually ends up exposing some level of technical debt, whether that be documentation, server infrastructure. Usually it's one of those two things that typically trips us up a little bit. So I'd say regardless of whether it's a new application for like a new junior mid developer, it doesn't matter what level of developer, I feel like that still needs to be like an initial way to like stick your toes in the water, be able to do something like, okay, I'm starting to understand a little bit more. Also, you can also touch on like how well the test suite is. If there is a test suite, can you reproduce the bug in a test suite, things like that. But I think those are good things to think about. Just assuming that maybe you have people on your engineering team that are across a wide variety of experience and skill set in terms of how long they've been in the industry or their experience and stuff. Do you find that there's a correlation between how people talk about technical debt and their experience level?
I would say most junior people are not very aware of technical debt and its implications, but more often than not, senior people don't fall into the same category. Some people, maybe that you wouldn't necessarily call senior, only 3 or 4 years of experience, but have had chance to work on big enterprise systems or big legacy systems and so on, will often know a lot more about tech debt than somebody who's been around for 8 years, but has only been doing small projects with very small teams and keep going to starting fresh every time.
So with all the third-party development tools that we have available today, including Rookout, do you think it is less complicated to manage the long-term maintainability of software now than it was, say, over a decade ago?
I would definitely say software maintainability is becoming easier. If I had to choose, I would point out 2 major changes that have occurred over the last decade or so that make it so much easier. The first is observability. There are so many observability tools out there, and there's a whole lot to be said about the benefits of observability. But one clear benefit is that it's easier for us to see what our software is doing. And so it's much easier for us to understand it. And instead of having a huge code base that it's a black box and you have to read through it and try to figure it out, you can run it and see in runtime how it's working. The second reason that's making it so much easier is the huge infrastructure boost we've seen over the last decades. Today, you can write the same application you wrote 10 years ago in a fraction of the code with much more advanced tooling, be it Node.js, new Java libraries, and so on. And when you're writing so few lines of code, it's also become much easier to maintain them as you're accumulating much less legacy.
So let's imagine that there is a software developer, I hope, listening to this podcast out there, who finds themselves working on a code base where the original developers are no longer part of it. They are struggling to figure out how to prioritize what they consider to be a mountain of technical debt due to lack of documentation, reliable test suite, etc. They're feeling a little overwhelmed on where to start. What advice might you offer them on how to best improve that situation starting today?
Surprisingly, the best approach to dealing with lack of knowledge and tech debt is simply reaching out to the people who wrote the code. While seemingly trivial, sitting for a cup of coffee with members of the original engineering team is a quick hack that can save you days of suffering.
What if those engineering developers ran away or are no longer to be found if you don't have that luxury?
So you would be surprised by how often how often it's just easy digging through the archives and giving a few phone calls. But if you're unable to do that, then start by getting the code to build and then get it to run. And then start playing around with it. See what happens. Set some breakpoints, maybe non-breaking breakpoints by Rookout. Write some log lines. Try and piece it out. What's going on? How is it working? It's all about observing the code to better understand it.
I wanted to quickly touch on another thing that you had mentioned earlier about, we've touched on quite a bit about observability, and there's a lot of like analytics tools out there and visualization tools. Do you find that everybody on the team kind of needs to think about these things, or do you find that there's certain types of people within those teams, like certain roles where they're more focused on kind of like analyzing the data and paying attention to that stuff? Because I sometimes wonder about, you're working on software, but you're also having a lot of data flow coming in, and how do you can kind of limit how much data is coming at you and how you can kind of cognitively manage that load from, we've got all this data coming in over here, but we're also just trying to build out some stuff over here. How do you balance that?
It's the 21st century. Everybody should be data-driven. It doesn't matter if you're working on the front end, on the back end, some SDK piece of code, or machine learning. I don't care. You don't want to write code in a lab. You don't want to be isolated from the real world. You want to observe your code as it's running in the real world. You want to collect data on how it's behaving. You want to collect data on how it's being used and what are users doing with it. And you want to learn from that feedback. You want to improve using that feedback. It's much better than writing your code in a lab, running it against tests, and trying to figure out from that if it's working properly and how to improve it.
All right, well, that's great. And so with that, I have just a couple last few questions. What book do you find yourself most often recommending software developers?
The answer would definitely be The Phoenix Project. It's an amazing book about DevOps journey for people who haven't seen much of DevOps, who haven't learned much about shift left, and sometimes even for developers who've been DevOps from day one, developers who grew up in startups and other places where they practice DevOps but never actually stopped to think about it. The Phoenix Project is a great book about showing you the fundamentals and in a very light spirit teaching you about it.
Great. And where can people learn more about you online?
Everybody is welcome to check us out at www.rookout.com. We have an online sign-up with a free tier, so feel free to check it out. And I would love to hear more from you on Twitter, LinkedIn, Facebook.
Excellent. Where can people find you on Twitter?
Liran_last.
Excellent. Well, it's been such a delight having you on Maintainable, Liran. Thank you for joining us.
Thank you for having me.